Good day, ladies and gentlemen. I welcome you all to Shito's Mathematics Coaching Program. At the end of this video, I urge everyone to share this video and do not forget to subscribe and hit the bell right beside the subscription position. So today, we are going to look at change of expressions to perfect square quadratic. So let's say, in order not to waste much of our time, because we've already stated how we determine, or how we can determine, or if we see an expression, so how we can determine that that expression is a perfect square quadratic expression. So today, how can we make, or let me say, how we can change an expression to perfect square quadratic? That's what we want to do. Definitely there will be something missing at that expression, so we are now to complete it. So now to complete it, so that it can make it what we can make it to be perfect square. That's what we want to do today. So now let's say we are giving this kind of question. That is, they said we should change the following to perfect square, and also we should factorize. If God permits us, we'll be able to factorize. But the main thing we are going to do here is how can we complete it to make it to make that expression a perfect square. So now the first one is we have x squared minus 6x. You can see x squared minus 6x. If you look at this one very well, our variable here is x, which means that x is the variable that we are looking for, and is having the highest power of x here is what? Is 2. That is why this is a quadratic, but it is not what? It is not complete as perfect square. You now want to make this expression to be what? To be perfect square. You understand? Because if we are to compare these expressions to general equation of quadratic, or let me say the general expression of quadratic, this is what we are going to have: ax squared plus bx plus c. If you look at this, if you are to compare this and this, you see that our constant here, the constant is not here. Therefore, it is the what? Is the one that is missing out here. So we are looking for our constant here. So now, what will be our constant here that will make this expression completed? To be completed. Are you getting what I'm saying now? So now, if you want to do that, the first thing you are going to do, we have two methods we can use. So I will use the first method, and also, if God permits us, we'll use the second method. So now, look at this. If you want to do this, you try to take the coefficient of x, that is the one that is having the power 1. You take the half of this coefficient, that is, what is the coefficient of x here is what? Is 6. You take the half of it and add to what? And add to the expression. That is it. That is that. So now the half of 6 is what? Half of 6 is, that is, half of 6, that is coefficient of x, is 6 over 2, then raised to power 2. Then 6 divided by 2 is the same thing as what? 3 raised to power 2. So now this is the half of the coefficients and the square. We squared it. This is the half of the coefficient of x, which is what? Which is 6. So we squared it. So we have what? We have 3 squared. So now the result, you now add the result to this expression. Therefore, we have x squared minus 6x. Do not forget, because we are having minus there, definitely we have minus there. That is half of minus 6. Understand? So do not do that mistake. Do not do that mistake. If we have minus there, make sure you include the minus there. So now we have plus minus 3 what? Minus 3 squared. Can you see that? Minus 3 squared. So now look at this. So now if you want to complete this one will be x squared minus 6x plus 9, because minus 3 times minus 3 will give us what? 9. Are you getting what I'm saying now? So this is what? X squared minus 6x plus 9. Are you getting it? So this is what we call, we have already made this one what? Make this expression completed here. So now as it is now, it is called what? It is called perfect square quadratic. Now if you now want to check whether it is actually perfect square quadratic, come back to this side. Are you getting this? Come back to this side and compare it with the general the general expression I wrote for you the other time. That is x squared minus 2xy plus y squared will be x minus y squared. Are you getting it? Now, if you want to know whether this one is what is right or not, okay, you now from this expression we have, you take the square root of the first term, which is x, and the square root of the what of the last term, which is what? 3. That is, the square root of 9 give us what? Give us 3. Now that is what? That is the first what? The first condition I mentioned. If you want to know or to want to determine that expression, I mean, what's it called? A perfect square quadratic is what? Is actually perfect square quadratic. Are you getting me? Or if you are given any form of expression and they ask you to determine whether it is perfect square quadratic, are you getting it? So I gave you, I stated 2 conditions to follow. That is 2 conditions to be what? To be held before you can affirm that this is what? This is perfect square quadratic. So now, and that's what I'm doing. The first what? The first condition ascertained here. At the same time, the second condition says the middle term must be what? Must be twice. That is 2 times the square root of what? Of the first term and the square root of the last term, which is what? 6s. We can see that we have our 6 here. Can you see? You can see that we have our 6 here. Definitely, automatically, since we have 6s here, which happen to be the what? The middle term here. Are you getting it? So if you now want to factor this, I think you want to factorize this one, definitely it will take the form of, you can see that this question, this one is same thing as this. It will not take the form of what? We take the form of x. That is, we are not going to use x, okay, x minus, because of this minus here, don't forget, 3 raised to power 2. So you can see we are given this and what? And we factorized it. Are you getting what I'm saying now? So that is that. So now, if you are given another question like this, let's say you are given another question. You are given another question. You are given another question. 2 like this. 2y squared minus 3y. This is the one. You can see that if you look at the first and the second expression, you see that the coefficient of x squared is what? Is unity. When they say unity, is 1. And the coefficient of y squared here, that is the one that is the highest what? The one that is having the highest power, which is what? Yeah, y squared. So you can see that the coefficient is what? Is not what? Is not 1, and it's not unity. It's more than 1. So which is what? Which is 2. Are you getting it? You can have 3. You can have minus integers. That is negative integers. You can have that. But look at this one. This one is not unity. That is, the coefficient of y squared is not what? Is not unity. But the coefficient of x squared here is what? Is 1, which is unity. Are you getting what I'm saying now? So now, look at this one now. If you want to do this one will take another form of solving before you can make it what? Before you can factorize and make it what? Perfect square. So now, if you want to change this one to perfect square, that is, you try to manipulate. Are you getting it? That is, 2 Try to bring out these two. Y squared minus 3 over 2y. So it is not in here. This thing just require an understanding. Look at this one now. If actually you want to open this bracket back, we have 2y squared minus 2 times 3 over 2y. You see that 2 will cancel 2 here. You left with 2y squared minus y, which minus what? Minus 3y, which took us back to our expression given to us. Are you getting what I'm saying now? But to make this a perfect square quadratic, so we are going to look it up in this way. I don't know. Are you getting what I'm saying? We are going to look it in this way. Therefore, you can see that we didn't change anything. Yes, we didn't change anything. So now, is this one in the bracket you change to perfect quadratic, what's it called? A perfect square quadratic. Understand? So 2 into bracket, what do? You take the half of the coefficient of what? Of y. That is, the half of it is minus 3 over 2 times 2. That is the half. You square it. So we have what? We have minus 3 over what? Over 4 all square. I don't know, maybe you are getting what I'm saying. All square. So now from there, this is the half of the coefficient. This is the square of the half of the coefficient of what? Of y. So how are you going to do it? And we say, after doing this, you will now add this back to the what? Back to the expression. So therefore, we have y squared minus 3 over 2y minus 3 over 2y minus 3 over 2y plus minus 3 over 4 all square. Minus 3 over 4 all square. Are you getting it? So I'd like to clean this one. So from there, you can see that this will result to 2 into bracket y squared minus 3 over 2y plus 3 squared will give us what? 9 over 4 squared. You give us what? Give us 16. Give us 16. Give us 16. Give us 16. So now you can see that this has become what? Has become perfect square quadratic. Yes, this has become perfect square quadratic. So if you want to know, bring out this one. If you want to know, you bring out this one, that is, if you want to know whether this is a perfect square, you have what? Y squared, which is y, you take the half of it, first condition. Then this one, 9 over 16, this one, the square root of 9 is what? Is 3, while the square root of 16 is what? Is 4. Are you getting it? So now, try to multiply. If you are trying to multiply, the second one, it means the middle term here must be 2 times y times 3 over 4, which is equal to 2 here 1, 2 in 4, 2. We have what? We have 3 over 2y. Can you see? You can see that 3 over 2y is what we have. For these two conditions to be what? To be satisfied, it means the one inside the bracket is called what? Is called a perfect square quadratic. So now, if you want to factor this one out, you don't need to stress yourself. It will just be, to factor this one, it will just be 2 into bracket, what is it? This, the square root of the first term, which is what? Y. Because of the minus, we have minus a. Are you guessing what I'm saying? Because of the minus, we have minus a. Then, look at this. The square root of the last term, which is 9 over 16, is what? Is 3 over 2. 3 over 2. No, 3 over 4. 3 over 4. This is the square root of this. 3 over 4. Then, all what? All square. Can you see? So this is the what? This is the solution. We completed this expression to be perfect square and we factorized. Okay, so now if you want to use the second method I told you, so we have the general method, that is for the discriminant. We call this discriminant equals to, maybe if you want to know the nature of root of quadratic equation, b squared minus 4ac. So where did we get this one? If you look at the quadratic formula is what? Minus b plus or minus b squared minus what? 4ac over 2a. So now we try to bring out this root. Understand? Because it's the one that is telling us that will tell us the nature of the root. That's why we brought it out. So we are now going to use this one to know. Understand? So if you bring out this b squared minus, if this one, you don't need this root. Yes, we don't need this root. This is what we need. B squared minus, if our discriminant, that is this one, now equals to 0, so we have b squared to be equals to 4ac. So this is the formula we are going to use. If you want to, so this, we call this what? B squared equals to 4ac. That is what we are going to use to make this one, to get the constant that must be added to this to make it what? To make it a perfect square quadratic. So now, how are we going to do now? So we try to compare, because if you have to compare this one to general expression of quadratic, you see that we have a s squared plus bs plus c. So this c is missing here. We need the constant. So we need the constant. So if you are to compare here, the coefficient of s squared is what? Is 1. The coefficient of x here is what? The coefficient of x here is what? Is 1. The coefficient of s squared, here is 1. The coefficient of s squared here is what? Is a. Definitely a equals to what? A is equals to 1 if you compare this and this. Understand? And the coefficient of what? X here is what? Minus 6. The coefficient of L is minus 6, which is our b. That is b equals to minus 6. Also, our c, we don't know it. C is still what? Is still same thing as what? As c. Or you call it any other constant. Maybe b or c or k. Anyone you want. Understand? So now, using this one now, you can see we've already known our a here. We've compared and we've already gotten our a to be 1, b to be what? Minus 6, c to be c. Are you getting it now? So from here now, we now bring this formula. B squared equals to 4ac. You try to divide through by c because we want to look for the what? The value of c. So therefore, making c the solid formula, we have c to be equals to b squared over 4a. Are you following? To be what? B squared over 4a. So now, from what we are given here, you can see that b squared, what is it? B here? Minus c squared over 4 times, what is a? What is our a here? A is what? Is 1. So we have 36 over 4. Again, so 36 divided by 4 will give us 9. Therefore, you can now complete this to be s squared minus s plus 9. You can see. If you compare this one to the results we have using the other method, that is taking this the coefficient, the half of the coefficient of x and square it and add it to what? To this. So look at the final answer. I get it and compare whether it is the same thing or not. Whether it is the same thing or not. So now that is that. So you can as well use this 2. You can as well use this the same method we have here. But the only thing here is that if you want to do this one, this is number 2. If you want to use that one, you make sure that your expression is what? Is not as this, because this one is different from this, because the coefficient, I told you earlier, the coefficient of x squared is what? Is unity, that is 1 here, while the coefficient of y squared is what? Is 2 here. They are different. So you now try to write this one so that it will be in this form. To write that one, 2y squared minus 2y can be equal to 2, bring the 2y, y squared minus 3 over 2y. So now, this one now, you try to take this one in form of this. Are you getting now? So now, our variable has changed to y. So it can be z, it can be anything. Our variable can be anything. Since you specify that this is what you are doing. So now, if you have that, so to take this one, if you want to compare it, to take this one now, our a will be 1, b will be minus 3 over 2, y, c will still the same thing as c, because we don't know, it's what we are looking for. So according to what we have here, so c will be equals to b squared over what? Over 4a. So what is b squared? B squared is this, we have minus 3 over 2 whole square over 4 times, what is a? 1 times 1. So we have our c to be 9 over 4 divided by what? Divided by 4. Can you see? Over 1. This division I change it to what? I change it to division sign. So from here, we have our c to be 9 over 4 multiplied by 1 over 4. This will be 9 over what? Over 16. Therefore, we can have this expression to be as perfect square as 2 into brackets y squared minus 3 over 2y plus 9 over 16. So if you can as well compare this result to the result of the other one we use for the other method, the first method we use. So that is how it's been solved. So this is the end of today's lesson. So I urge you to share this video to people to see that mathematics is simple. And at the same time, do not forget to subscribe, please and please. Subscribe and hit that bell right beside the subscription position. So I greet you once again. I remain myself, Shitu. This is the end of today. Take care of yourself.